Okay.
Oh.
Maybe there's a Pigeon Falls out there at least at some point.
Kyle says there's a Pigeon River in Sheboygan.
Okay. I don't think it's that one. I don't think it runs all the way to Sheboygan. I could be wrong.
It'd be quite a long river.
It would be quite a long river. All right, so 12:15. I think we'll get started here. I'll start with we'll start with the day cloud phase distinction RGB. Or actually, if you would go to the week, we'll start with a week-long IR satellite movie. So. First thing to note here at the beginning of the loop is this incredible cold air outbreak that the Northeast experienced, record-setting in many locations. Interior Maine, you had places, just at regular service level getting down to wind chills in the -60s. Mountain Washington recorded a wind chill of -108, which was a record in the recorded era. I saw some interesting climatology analysis that suggested it may have happened again about 140 years ago in the late 1880s, but obviously no verification there. You can see these incredibly cold surface temperatures popping up here in the 230 kind of Kelvin range, which is bone chilling. And then as we go around another iteration of the loop, it's really cool to watch as the cold air kind of floods out over the Northwest Atlantic there. You get some really cool open cellular convection. I'll just kind of wait for it to loop again here.
I can almost queue it up.
Oh yeah, I think we're almost there anyways, but if you actually stop it kind of towards the beginning or maybe right there, you can see that cold air just flood out following this very impressive mid-latitude cyclone transitioning up towards Greenland all over the North Atlantic. So yeah, that's just a really cool event. Look at this broad area of incredibly cold surface temperatures. So, and you can see the entire continental United States also looks pretty chilly on this as well. So if you play it again, thank you. So we'll now kind of take a look at the disturbance that caused us to get some snow yesterday. Pretty impressive snow event. We'll also comment on this explosive cyclogenesis event off the East Coast here. I'm not sure exactly how quickly or rapidly that deepened or where it ended up, but very impressive, at least in the infrared. You can see now this cyclone generate over Oklahoma and then move northeast over us. You can see this deformation band set up right over us. The coldest cloud tops there gave us, I think 4.3 inches, or 4.8 at the airport. Yeah. I have some incredibly heavy high snow to liquid ratios. I'll talk about that in a second. But yeah, and then you can see that kind of dissipate rather quickly. It was we were in the perfect spot there to get the heaviest snow that system could possibly produce. And then I think that's most of what I wanted to comment on that. So Pete, would you go back to the cloud phase RGB over southern Wisconsin, please? We can just kind of take a look at just how narrow that snow band was.
I'll just point out what happened in Boston. They were -10 on Saturday and they were 51 for a high on Sunday.
Wow.
It's the biggest 36-hour temperature swing they've had since the 1880s, I think.
That is wild.
Incredible.
It's got to create some heat stress on it.
Yeah, you would think. Not something people want to go through again.
So you can see just this incredibly narrow band of snow. I mean, it can't be more than probably 100 kilometers from side to side, and we're kind of right here in the center of it. So, if you're a snow lover, that event went about as well as it could have. So I had a graphic, Pete, that if you would pull up, I wanted to figure out just exactly how abnormal the high snow to liquid ratios we were seeing yesterday was. So. Using the airport reports, we had about 0.63 of inches of liquid equivalent precipitation, which equated to 4 inches of snow, giving us a 7.6 to 1 snow to liquid ratio. And I looked at this paper, a little bit dated, but it was the most updated climatology of SLRs I could find for the CONUS. And so I've plotted this, or I have this graphic here that was attached to the paper of the Milwaukee-Sullivan climatological snow to liquid ratio. As you can see, we're well below even the 25th percentile of snow to liquid ratios, so kind of a fairly rare event, especially I would assume for early February. They didn't do too much decomposition of that, but I would expect that it's especially rare to see it at this point. So if you're wondering why the snow felt like cement yesterday, that's why. And Caitlin had also brought up that we actually didn't even get below freezing yesterday.
Is that right?
Yeah.
Wow.
We had a high of 38 and the low was 33.
Wow.
And so I was really impressed at how quickly it piled up on the roads, which kind of is a testament to the impressive forcing that was generating those crazy snowfall rates.
Yeah, the rate of snowfall was remarkable, and that cools the column by sublimation. So you can, all the air that's around those snowflakes was well below freezing, but the air temperature outside of them was not. Pretty amazing.
It was a really cool event. Yeah, so now if you want to go to, if you go to the visible observation, or just the visible satellite loop for today, Pete, that'd be wonderful. Comments on the weather ongoing across the CONUS. So you can see we've got pretty quiet weather across much of the continental United States here. There's this band of presumed cloudiness, and we'll see if it's precipitating at all on radar. I looked before, it didn't appear to be. Perhaps a nascent surface cyclone of some sort here. You can kind of see some cyclonic curvature there, and just kind of a broad band also of cloudiness across the southeast here. Looks like a pretty impressive cyclone here to the southeast of Greenland. But overall, nothing too conspicuous to comment on across the continental United States. You can kind of see the remnants of what brought us our snow yesterday, but really nothing too incredibly impressively organized, I would say. And you know, you can see this extremely narrow swath of snow as well, which is, you know, this gives a good idea of kind of the scale of that. And very snowy here across the west as well. I didn't comment on it on the week-long IR loop, but you could really see some more graphic lift creating some pretty impressive snow across the west as well. Now if you would, Pete, let's go take a look at our surface observations.
Do you want the radar? Or
Oh, actually, yeah, that'd be great. We can go to the radar first.
Not
Just to
much
see
to
if there's
see on
any-
that, I suppose.
Yeah, I was gonna say, so nothing really too impressive to note. Some spotty, some broad area of precipitation here, getting kind of into the 55 dBz range, so probably some pretty heavy precipitation off the southern Gulf Coast here, but across, you know, much of the continental United States, really nothing of note. Small area of precipitation in western Arkansas. We can see if we can diagnose what's causing that. But other than that, very quiet weather. You know, you wouldn't really have any indication that we had 4 to 5 inches of snow yesterday. I think there was a report of 8 inches in northwest Dane County, so.
Near Lodi.
Yeah, so kind of, you know, again, as we've been saying, kind of an impressively localized event. Yeah, so now if we wanted to go towards the surface observations, if you would, yeah, we'll go down towards Wisconsin. So not too terrible a day here, 26/7 with about 10 knots of northwesterly wind, so probably pretty seasonable. Certainly nothing like the cold we had over the past couple of weeks. So you can see this band of cloudiness in the observations, broadly cloudy across southeastern Canada and all the way down here from central Oklahoma up towards the east coast, southern Maine. Temperatures broadly in the mid-30s to low 40s. Just some pretty evident frontal boundary here associated with probably, I'm trying to see if I can find this here, but it's either low pressure, probably up here. Don't know the eastern Canadian provinces. Caitlin, would you help? Southern Quebec. But nothing too terribly exciting. Probably about a 1,000 millibar surface low. Lowest observations there is 1,000.1. So yeah, nothing too terribly exciting there. And clear across the western half of the country. One thing I was noting earlier is you can kind of see this temperature contrast here. It's about 27 in, it's not North Platte, is it? Kearney maybe? I think this one's Grand Island. Anyways, there's about a 10-degree temperature contrast here in central Nebraska, and that lined up pretty well with what looked like a swath of snow on the visible satellites. You can kind of see the effect that is having on the surface temperatures there, but otherwise, nothing too impressive across the United States to note there. Some snow observations here in southern Quebec, but other than that, it's pretty much the only precipitation that's being reported.
Some unbelievable temperatures in New England. 61 at Hartford, 63 at Providence, and 59 at Boston, all with westerly winds. You
That's a
can't,
great
if
point.
you have an easterly wind, it's 48 or 45. The westerly wind today, unbelievable how warm it is.
That's a great
February
point.
10th. Jeez.
I don't feel nice.
Yeah.
Down in Miami still remains free from the cold as well if we scroll down here. Beautiful 82 over 68 in Miami, 81 over 71 in Key West. Still sweating it out down there.
Who wants it?
No, exactly. All right, Pete, would you pull up the 500 millibar super Pete? We can take a look at kind of the upper air pattern over us right now. So some pretty wavy flow.
Wow, look at that.
Yeah, so we got a trough coming in off the west coast here, broad ridge axis across the Intermountain West, and then this pretty deep, positively tilted trough. And you can kind of see a short wave in the flow here that I'm assuming is the disturbance that caused our snow yesterday. And you can really see it's fairly meager at this point. Nothing really Nothing obvious, and it's probably what I would guess is producing that bit of precipitation across southern Quebec as well. But a very deep trough here, and Pete, would you do me a huge favor and go back to the surface observations here? I just want to see if that band of cyclonic clouds that we had noted on radar has any surface signature down there across southern Oklahoma and northwest Texas.
It's cloudy.
It is cloudy. Yeah.
Rain
so
in Houston.
Snow in southern Oklahoma.
That is interesting. So I mean, nothing. There's not too much, curvature here, but some precipitation, and maybe that's being produced by kind of the curvature at the base of that 500 millibar trough that we looked at. But nothing that leads me to say that there's kind of a obvious surface cyclone there at all.
Yeah, no.
So that's interesting. If you go back to the 500, that'd be great. Thank you. So yeah, that's located kind of right where you'd expect to see precipitation, just downstream of the base of that trough. We could probably look and see. Would you be able to pull up the QG Omega diagnostics?
There's confluence in there too. You think of
Yeah.
the flow from Kansas City across to central Illinois on that streamline, and then the one that comes from Dallas up would
You just
also
wanna
be like that.
Do the total QG Omega maybe forecast hour 6.
I think this is from run from 0Z. So this.
Oh, okay.
Let's go to
So we
18.
went 12 then.
Yeah, 12 would be the exact match to that map.
So yeah, a little bit of, this is ascent, right?
Yeah, yellow's
Alright.
ascent. Yeah.
So yeah, a little bit of QG Omega ascent kind of forced at the base of this trough, really collocated almost exactly with where we saw it. And kind of an impressive signature across southern Quebec with that shortwave there, with large area of. Do you know what are the contour intervals on that?
Every decipascal per second, which is
Okay.
about a microbar per second.
Okay.
So that's 1, 2, 3, 4, 5 there.
Yeah, large area centering at 5 decipascals per second there, so kind of an impressive signature for what really wasn't too impressive. Although this is at 700 millibars, so perhaps it has a more impressive manifestation there. I guess we could go check that out. And before we leave, I'll also note this really impressive couplet off the west coast associated with that 500 millibar trough we noted as well. Would you go to the 700 millibar super repeat as well? We can kind of take a look and see how that matches up. So yeah, a little bit more impressive here at 700 millibars, closed off low. But yeah, again, nothing too terribly impressive, I wouldn't say.
There's confluence there over the St. Lawrence River at both 500 and 700, and here there's a reasonable enough temperature contrast that it matters. At 500, I think it's grinding that trough away to nothing. It's like a meat grinder.
Yeah.
But at this level, the thermal advection's strong enough and differential enough to produce a decent amount of ascent. So
Okay.
that might be what's going on there.
Excellent. I think that's most of what I had for the current weather. Pete, would you pull up the 850 cold pool map?
I don't know if I have that.
I think I sent it to you, I think I sent it to you in an email about 15 minutes ago. Sorry if that didn't get through.
Because I did pick the other PDF that you had. But yes, I have a lot of tag emails.
Sorry, I didn't mean to.
No, that's okay.
Yeah, I think that one. There we go. So Professor Martin sent me this morning. Would you fill in the details for this?
Yeah, sure. So this is the daily aerial extent of the 850 millibar cold pool, measured from the GFS 1 degree data every day. And so the blue line in the middle, the solid blue line, is the average for each calendar day, and it goes from December 1 to February 28. And then the shading is 1 plus and minus 1 standard deviation, and then the daily high of all time in 75 years and daily minimum for 75 years of the thin blue lines. So for the first time since early or mid-December, we're above the average. We were last week anyway, when it was cold. And remember, there was the really big cold air outbreak in China, where we had the really record temperatures at so-called China's North Pole. It's coincident with this March, the steady increase in the cold pool aerial extent that started just before our snow event, maybe 22nd or so of January, and ended on the 3rd of February. So that's almost an unmitigated march upward to get above the average, which just doesn't happen very often anymore. And then we've got a decrease since then. But this time series is through the 8th of February is the 15th warmest, so smallest area integrated across those days in the 75 years of the time series. I thought it was going to fall further down on the list, but it only fell to 15 with this giant increase. So I guess we have a chance to make up some ground and stay in maybe the 10 warmest if we really get warm the rest of February. But whether that happens or not, we don't know.
You were saying we were like 7th warmest at this point. Is that
Yeah,
correct?
that's right. Yeah, we got as high as 7 on the list, but I don't think we'll see those lofty positions again this year. No.
Excellent. All right, I'll hand it off to Kaylin now for the forecast.
All right, sweet. So I'll quickly run over what we might expect this weekend, some upcoming weather, and then just for fun, we'll look at some eye candy in the forecast. So can we start with the Python plug?
This one probably right, the
Yeah,
report grid.
yeah. Can we do the H column, please? Just for 3 hours. Run through that quickly. So, so this is currently right now. This is the 3-hour cumulative precipitation in colors pinks and purples, the thickness in yellow, and the pressure in blue. So, as Isaac mentioned, we're in pretty calm weather, no precipitation across the U.S. with the band of precip from the GFS, clarified, stretching across all over the coast. So, in some, I guess, weekly warm advection to our northwest. Nothing really going on over us here in Wisconsin, but by the looks of it, we should have a warming trend through the weekend, and looks to be dry with no major features coming through at least Sunday, Monday. So we could go for 12 hours to.
Can we just stop for a second, Caleb?
Yeah.
I'm struck by the insignificant look that cyclone off the Northern California, Southern Oregon coast has in the forecast. We I think correctly pointed out there's a strong vertical motion max. We didn't look at the West Coast satellite image, which has a pretty decent structure for that thing. But look at that, the central pressure is 1,020 if we're lucky. I mean, isn't that wild? Yeah, very weird.
I hadn't looked at how it evolves in the forecast though.
Yeah, me either. I had no idea. I just kind of noticed it as a structure on the satellite, and now to see it with that signature at sea level in an immediate forecast, effectively an analysis,
Yeah.
you just think, wow, that's weird.
So if we go forward, yeah. So this is tonight. Once again, warm advection. It's not exactly the greatest warm advection, but it's still, you have reservoirs across increasing thicknesses, and this precipitation, the upper level low has now kind of become cut off in this sense, and we might see development furthermore as it goes eastward. And as you had mentioned, Professor Martin, just no real oomph to that storm.
Yeah, it's 2 examples. I mean, even the trough over Texas, Oklahoma, and Missouri sits on top of an anticyclone. And then this feature at upper level sits on top of the eastern periphery of an anticyclone and puts a little bit of a dent in it, but that's about all it can do.
Though I will say, in the over the weekend, both of these will develop into proper cyclones, so there's some redeeming factors. So if we go forward 12 hours, so this is tomorrow morning, Saturday morning, and this feature down across the southeast is now developed into a proper cyclone with 14 over here, sorry, mix up. Upper level lows over here, 10, 14 down here. And this cyclone over here will be watching that. But once again, dry weather of us, some westerly winds, not too much temperature direction, though, yeah, pretty nice weekend so far. If we go forward 12 hours again, and this cyclone has now begun to develop under the influence of the upper level low, and now we're down to 10:12, or 10:07 rather, with some substantial precipitation across the southeast, across the Carolinas, Georgia, Alabama, and this cyclone off the west coast still meandering around, not doing much, but over us, dry again. So we go forward to Sunday morning, 12 hours, and we see that this cyclone now is down to 10:06. Once again, some substantial precipitation, but over us, dry and pretty nice, I'd say. I'll bring up the temperatures afterwards, but nothing going on. So we go to Sunday night. Yeah, dry weekend. Some Short wave approaching on Sunday night, but it'll be here for the next following week. But over the weekend, should see some sunny skies, no real precipitation, and nice weather to go out, I guess. And this cyclone now has dropped to 10:08, and this will be what will drive our weather in the coming week. So if we could go forward 24 hours. So now we start to see some development and precipitation in the desert southwest. We still have some meager warmer advection here with the 540 line well north of us, so it'll be decent weather. Cyclone over off the Carolina coast now down to 988, and we start to see another short wave, or precipitation area rather, move on to the west coast. So if we go forward 12 hours again, we start to see the development of a cyclone, and this is down to 991, but it's pretty sad looking for a sub 990 or sub 992 low with little precipitation. And we start to see some warmer advection with winds coming from the south, and we go from pretty solid 546 thickness over us. So should see some rain if we go forward 12 hours again. Approaching Tuesday night, Tuesday afternoon, you should see precipitation. That should be in the form of liquid time, or liquid precipitation, because 540 line is well to our north. So it's very unlikely to see any snow or any of that equivalent. And then can we pull up the fire removal board? Which is speed for this? I just want to show that this cyclone is 990, but the upper level structure for it, for the entire process, is a bit.
What time was that, like 90?
108.
108, yeah. Or actually, can we just go to 90? Actually, I want to show 90 first. 90. So here's the upper level low that we saw on the super beats finally making its way through the southwest, or desert southwest, on Tuesday morning, or Tuesday, yeah. And it's finally moved out to the desert south area of Texas, and we see PVA by the geostrophic wind. We can see the geostrophic winds like this contour the geopotential heights, vorticities in the fill. So we see the geostrophic wind would be parallel to these lines, and we see positive vorticity here, and we start to see the PVA in this general area where we see ascent in this region potentially, and that's exactly where we saw the 990 low also occur in this general vicinity. To me, it just seems like the low is fairly low for a type of a weak upper disturbance like this. I don't know, maybe
No, I think you're right. That storm and the one that's off the East Coast. By the time we get to this point, they struggled for a long period of time when the upper waves presumably were even better organized than they are at the times when finally something starts to happen with both of them. So boy, it's like the little engine that could in both of these storms. And by the time they start to get organized, aspects of the structure aloft are a little bit less organized than you'd like, and maybe the timing just is off. Because really, you're always dealing with whatever's going on in the lower part of the troposphere and how it joins up and kind of partners with the stuff in the upper troposphere. And it's quite often the case that the timing's just wrong, and the spacing's wrong, and everything about the phasing's wrong. And for a while, that seems to be the case with this.
Yeah, so that's the focus of that storm. But this incoming trough here will be something to keep an eye on for next Thursday as well. So if we could go to 108 with this now.
Yeah, it becomes a very impressive feature. Look at that.
So this trough becomes very impressive. The trough acts somewhere along here. This is the initial feature, and it's encompassing basically everywhere west of the Rocky Mountains. This entire trough with some substantial geostrophic wind. So you assume there's a strong wind there, and double barrel troughs. That, in my opinion, is a very good idea for us in the Midwest. Usually the first one leads to drop in temperatures, the second one, there's your storm. So if we can go to 120, yeah, beautiful upper level trough, right in the center, basically over the Four Corners region. And we'll see the geostrophic wind begin to affect PVA through the geostrophic wind towards our area. We should see development of a cyclone somewhere in this general vicinity in the coming day. So if we go 12
Yeah, and that vortex strip that was even more impressive at the prior time is a really deep trench in the tropopause. So there's a lot of PV that's come down into the middle troposphere in that region.
Yeah. we go 12 hours. Start to see it kind of stretches out a little less defined, but still very potent. And now the trough kind of axis basically leads to a polar tropical or polar vortex up here, stretching all the way down to Arizona area. So it's very potent, and if we go 12 hours again. Sorry.
Yeah, before we go, I just want to say, I don't like to see such a linear feature. That makes me nervous that there's not going to be any wrap-up over Nebraska, Iowa, which we really want to get for a big storm. But not that it won't be impactful, but it'll be of a different variety.
Check out that strip over there in the Pacific Ocean too. That's just a really fun.
That thing's going to wrap up at the southern end.
I've been watching that. It's so tightly packed.
Yeah.
On two sides.
So if we go, can we just go to the precip at this time at 132? So we have a very nicely photogenical area. So we have, what is this, I don't know what thickness,
64.
564 to 534 here it is, in a very short area. So there's a probably strong temperature contrast between central Texas and New Mexico, northern New Mexico. So we can just kind of assume that along the storm would track, maybe along here, which is pretty favorable for us in the Midwest. There's initial 998 and 106-ish, 108-ish up here. 1,000, sorry, remember, 1,000 surface low now. And we go forward 12 hours. We can see that.
The orientation of the thickness lines vis-a-vis the vorticity makes it hard to really develop this thing. It's a lot of aeroconicity, but the development is going to take some time.
Yeah, so we're down to 996, and the storm's not completely organized, I'd say. You got this in cold side, warm side, but they're not completely combined in a sense to the max of their potential, I'd say, for a winter weather perspective. But on the northern side, Wisconsin's right here. We got a good area of snow north of the 540 line, and a good area of rain potentially south of there. And if you go to the
Something really quick too. Look at like we've been saying again on the West Coast. There's a really kind of not really any surface manifestation of that impressive upward feature.
One after another.
Eastern periphery of just a pretty impressive anticyclone there.
Right, that anticyclone is keeping the jet shunted to the west, and everything's struggling to develop in those locations. Even though the upper level development's not struggling, lower level development's a real task in the Eastern Pacific this coming week, it looks like.
So if we go 6 hours ahead to 18Z on Thursday, so basically the same time as yesterday when we got snow, they're down to 989. Yeah, so it does wrap up basically over Madison, and there's a chance for snow. We have 0.25 QPF or 0.17 and 0.25 QPF in the last 3 hours over Madison, and presumably this would be snow. The 540 line basically goes over Madison, so it'll be a tight fit based on this particular model.
What's the 500 millibar vorticity structure?
Yeah, I was going to say, can we go to 500 millibar at this point? And we have a little short wave that developed within this trough that has helped redevelop this surface cyclone as it moved through the Midwest from Ohio River. And once again, up level low, no surface, really 1024 high surface low. But so that's basically it. There's a chance there's a storm moving up from this trough off the west coast and finally moves through. Chance of rain, snow. We're on the line once again. Story of the winter.
Yeah, and we get linear precipitation bands in the initial stages of this development, and that makes it difficult to build that ridge up over, at this time you'd want it over northern Wisconsin, Upper Peninsula. It might just be beginning to do that now because the precipitation forecast seems to, hint at a self-development period that might come next. So just a little bit, if this works out, it's just a little bit too late for really the best event.
If we go to tropical surface, we can better visualize it. Forecast data. would start at 120. So this is the initial low that I had talked about. We stick to the terrain basically, and this is where the surface cyclone or the trough kind of sees. You can see thickest line is down to 528, all the way to California. It's going to be cold for them. And 1032 high in the Ancient Mountain West with the Colorado low, or Lee Side trough forming rather, just off of the Oklahoma panhandle with a little thermal ridge between the pressure, lowest pressure, 990. So if you go forward, click forward a little bit, start to see down to 990 where exactly where the Lee Side trough was. Colorado getting a pretty substantial snowstorm, 996, and continually see these tightening, the thermal or the gradient, and as this is probably the most linear where we saw the linearity of that trough feature, and then it redevelops as it continues. So if you go forward 6 hours, down to 995 with some more development, and you can see the two separation, like the cold snow and the rain, and then you go forward again. Now they're more merged, dropping down to 989 with a very substantial temperature gradient, 522 thickness here, and 552 basically here in central Illinois. So pretty substantial. If you go forward 6 hours again, on the back end there just might be enough cold air with enough moisture for to bring out some snow in the back end, based on the 12Z GFS model. If we could go to the Canadian model.
Sorry, real quick, when are we at in time here?
Oh, sorry, this is Thursday, so basically
Thursday night.
Thursday night?
6 o'clock.
Yeah.
Okay, thank you.
Yeah, sorry, I should have
Sorry,
mentioned
thank
that.
you.
So if we go to the global models up here, as well as other models, the Canadian, CMC. So this is a Canadian model. It's a bit slower, but similar. Madison, central Wisconsin on the line of rain, snow.
I think substantially weaker cyclone at this particular time, right?
98, yeah.
Instead of 974 or something?
It was 979 the GFS.
Okay, 978, so
Yeah.
that's, and it seems like it hasn't, even the Canadian model hasn't begun any of the self-development that I think probably is gonna be the story of this thing. It either does that or doesn't, so this might be the right solution.
Yeah, and the Canadian is slightly less colder with the cold following it, so we're down to 516 thickness here. If we go back to the GFS real quick, it has the thickness down to 504, so substantially less, or more mild air when following this cyclone. And now, if we go, we can move forward a little bit to 258. This is for fun. This is GFS Fantasyland. This is not going to happen, but
Where's Mike when you need
You're
him?
no kidding, this
Yeah.
is Morgan territory.
He used
That's
to do that all the
Yeah,
time.
so-
Just for fun, let's go look at 384.
yeah. So I normally don't go this far, but I just had to for this storm. It seems normal.
Similar setup.
Yeah, very similar
Colorado
setup,
low,
yeah.
Lee Side trough, thickness lines basically plastered across the Great Plains, Midwest, Great Lakes.
We've got a little bit of a nice little high over
Yep.
Dakota, South Dakota for support.
A solid, and then if you just click forward slowly, see it's 997, 997, 991, 981, 975.
That's a major event.
Oh,
So what's the upper vortex look like?
Yeah, so
Look at the thickness feel is just beautiful. So you can
That's a
see
very
nice
nice looking
thermal
storm.
rates.
So we go, vortex in wind. Yeah, you go back.
Wow.
You get it. It doesn't seem like the greatest, It
Yeah.
starts off, you don't have the big drop.
Well,
it just,
the thing that I like better about this, and it's why I think it comes out this way, look at the downstream ridge. There's already some downstream ridging. And this is a kind of compact, isotropic looking upper vortex as opposed to the current one that you're talking about for next week, which is linear, very strongly linear, upper front driven. And it never gets involved in a trophiness feature. But what's the next time at this peak? Yeah, that's, look at the ridge building over Iowa.
you got
One more time. Oh yeah, that's perfect.
115 knots basically around here at 5 millibars. That's substantial.
That's so good that you know it won't happen.
Exactly.
Yeah. It's also fun. We go.
I mean, look at, it's just a beautiful upper structure for a
Yeah.
walloping of snow.
Yeah.
over the
Look at
upper
this
Mississippi
upstream
Valley.
ridge has developed again.
Yeah.
Yeah.
70 knots across this entire region.
That's
crazy.
crazy.
That's a very nice upper
Yeah,
disturbance.
just to finish off the fantasy, we had to get snowfall. So if we go to Pivotal,
What's the accumulated for this?
Yeah.
yeah, I was just going to get to that.
quantifying while living here.
Yes, exactly, exactly.
So.
You have to
I'll
calibrate.
preface this by saying this is probably some of the most ridiculous deterministic
Yeah, so
output
if we,
I've ever
actually,
seen
can we
in
go
my
to
entire life.
300, just 300?
Yeah.
And then
Do the 24-hour
Yeah.
start.
At 300 hours.
300 hours, so we can go, and then we do 24-hour QPF, just, and then go to, zoom in on the Midwest.
So preposterous amount of QPF there.
All right, that's enough editorializing. I
Regional.
want to see it unvarnished.
So, this, oh, can we go back actually? I think it might be 294. Yeah, so this is,
Whoa.
this red is 2 inches of QPF. and
Wow.
Conceivably, this would be all snow.
Yeah.
You know, Madison, not in the snow. But this is just QPF. This is not accounting for anything else. It's just pure the liquid content. So we got 0.63 inches of liquid QPF of snow yesterday. Imagine 2.5 inches of QPF.
Yeah. Imagine Kuchera
Yeah, so
deciding
if we-
what
if
it
We
we-
don't
is.
have to imagine these.
Yeah.
We're very close to
Yeah,
seeing it, actually.
winter weather. Let's start with 10 to 1. Let's start with
Yeah,
10 to 1.
10 to 1.
10 to 1. 24.
Whoa.
So you're averaging over an inch per hour at 10 to
Whoa,
1 for
45
24
This
hours.
is only 24 hours.
These amounts do occur sometimes.
Yeah. And then if we go to Kuchera.
Kuchera.
for the-
So you're quite cold on the northwest side of this one,
Yeah.
especially too. So your ratios will be.
Yeah, 38 inches of snow.
Mind you, this is 24 hours, so this is
Oh, my 48 inches of
per
snow.
hour for an entire day.
And just for the heck of it, can we pull up the total Kuchera? This model did not like northern New England.
Wow.
89.
89 inches of snow.
So this is factoring in that earlier storm
Yeah,
back
yeah,
on
yeah.
Thursday as well, but
Wow. Yeah. I'd
wanna
love
take
for
a-
this to verify, you know, maybe we just have records, but.
do you want to take a sounding really quick too
Yes,
from
can we go to
the?
tropical?
That's
That'd be-
astounding.
Yes, that's what I wanted.
I mean, so this is technically a physical solution, but
Not a real solution.
Well, you know, we should
Yeah, so.
guard our skepticism. Who
Yeah,
knows?
22. And then go to the precip moisture. And then can we just take a cross section like right here?
Yeah, look at that. That's modern technology right there.
So,
Whoa.
this is,
That is
Incredibly
this
deep
is
omega.
northwest, this is southeast.
Yeah.
Incredible FGen. Freezing level. Whoosh, up.
Yeah.
And then we go PV.
Can't tell if we, yeah, what's the structure? Is it-
Oh my god.
See it?
Wow. That's like an occluded structure, because look at that big hole in the PV. That's been eroded by the latent heating. So you got this massive positive anomaly at 400 millibars to the southeast, and then another one to the northwest, and then the frontal boundary in the middle. That is really dramatic.
Oh, and then can we just
Wow.
take a smaller cross section just across Iowa?
Oh, plus, don't forget those winds.
yeah.
70 knot winds at 800 millibars. On, right there,
Oh,
right with
you
it,
can
right
see,
there.
we can see, if we go to lower dynamics, we can see the actual field, the whole wind
Wow.
field. Go to lower dynamics and go to 850.
Wind, maybe.
Warden wind.
Height and wind, yeah, height and
Oh,
wind.
height wind's better.
This is,
Whoa.
so constant red is 50 knots. You have 850 winds, the entire easterly coast.
70 knot range.
And then this is, pink is 64, so that's basically a hurricane strength
Wow.
at 850.
And look at the scale. I'll point out the scale of those hurricanes.
Ridiculous.
Hurricane strength winds.
Yeah.
It's over a wide area.
Yeah, and it's just insane. And then
We
if we
win
just take a
again.
cross section across just Iowa, right? Just across, like from northwest Iowa. Yeah, there we go. To like south. There we go. Yeah. Just that. Yep. You can see the frontal structure is actually insane.
Yeah, very, very
You know,
awesome.
it's just not like a mid-level front, and it's actually, you can just connect the whole thing with
Yeah.
positive omega. So this is basically ascent. You have strong ascent within the frontal regions, and if you go to the height and go to RH and omega, this is ascent is occurring in extremely moist or
Yeah.
extremely moist area. So this is one of the most proficient, you know, snowmakers you can imagine. You know, 43 inches in
Yeah.
24 hours, definitely one of those. And just for fun, can we take a sounding?
Yeah.
Right, yes,
Can
Hamish.
we jump to the southern hemisphere before we finish up today?
Yes.
Cyclone Gabrielle is pretty interesting.
Awesome. Yeah. Yeah, just there. Perfect.
Oh,
So,
look at that. Saturated to 350
Yeah.
millibars.
the gen-
Look at the amount of omega in the 700 to 600
Yeah.
milliwatt. It's just ridiculous.
It's straddling basically the 10, negative 10, and then you got some steep laps rates above, just far in front of it, and P watts near 0.5 inches, which is substantial for middle of winter.
If I took this sounding from a storm day, I would assume it'd be convectively contaminated. I mean, that's a preposterous.
That's an
amount of
intense
waste.
structure right in there. That kind of like in the warm frontal portion of the occluded structure. That is remarkable.
But,
Wow.
That's just, it'll be gone next run, don't worry.
Keep an eye on the mile variability.
But it's fun to look at, as a weather fan. But, any
Well,
questions?
I guess there was a time, I'll just remind you, you guys are hinting at it, there was a time when you looked at these things and you said, oh, this is so ridiculous as to not even entertain it. But now these are, as you pointed out, a physical solution. It may not turn out to be right, but it's not, ridiculous fantasy. One could learn something from interrogating this thing about how these storms organize, even if it doesn't verify.
Yeah.
Wow.
I came in late, so I don't know if you showed it, but did any of you all put up the satellite over Wisconsin this morning to see where those, you already did?
Yeah.
Yeah.
Okay,
Oh,
never mind. I just want to make sure everyone got to see it. It's so
Yeah.
beautiful,
So
but
cool, yeah.
Southern Hemisphere, yeah.
Hamish, do you have a website you want to go to?
Let's stay on tropical for a bit.
Okay.
Just jump to regions. Down left. Yeah. South Pacific. Southwest Pacific. Yeah. Back to current day.
Yeah.
So this is Gabrielle, Category 3 tropical cyclone, hurricane, based on the Australian record. But for reference, this is Fiji here and Samoa and Tonga. This is where they usually hang out. Like Gabrielle is all the way over here, and it's still a categorized cyclone. And if you pull this forward in time, you just see it's going in a straight line, straight across Auckland. So if you just pull that time step forward, it's going straight down, exploding. So it's no longer ranked as a category cyclone, and they never do by the time they make it down here. By the time we get about here, the temperatures of the ocean drop too much. But if any of you know, the Tasman Sea and then the Coral Sea up here are really hot. That's our western boundary current there. So it's very hot oceans in the Coral Sea. And so for this thing to be sitting up here, well, that's what allows it to be able to sit here as a categorized cyclone. And we are, if we get if we just Google the tracks, if we jump into...
Auckland just had a terrible flood like 10 days ago.
Yeah, so 2 weeks ago, Auckland had some pretty devastating flooding. And if you know Auckland, the whole thing is a harbour.
What's the name of it?
If you search up TC Gabrielle track and then zoom Earth.
Yeah, I think if you go to current storm time.
Yeah, that first one there. And if you zoom in on that. And so we are in a phase 6 MJO as well, which means deep convection over, zoom out a bit, deep convection over Indonesia, Papua New Guinea. So we have very moist conditions here, and it's also La Nina, which means hot ocean for the whole Southwest Pacific. So it's perfect conditions for this thing to set up as a tropical cyclone here, and it's the track directly southwest.
Wow.
Yeah. And then the other thing is that it's already starting to transition. So we have this
frontal.
subtropical jet that's quite displaced equatorward, which is associated with when we get deep convection over Papua New Guinea, we get that split jet structure, which is a typical southern hemisphere feature. Where we get enhanced subtropical jet up here, and then our polar jet gets pushed right down here. And so it's already caught up in that upper level jet stream. I don't know how common that is for a tropical cyclone to be categorized as a TC and be sort of undergoing transitioning at the same time. So it's almost been handed over to the mid-latitudes sort of very efficiently, and it just tracks straight down across Auckland and then straight down south. And so they're already talking about evacuations in Auckland. It's going to be pretty devastating, and yeah, just 2 weeks ago. So it's very moist there already. And so there is a lot of concern. They're citing this as the worst storm of the century, sort of on record, but 2 weeks ago we had the worst flooding on record already. So there's a lot of uncertainty about what's going to happen up in Auckland. If you zoom into Auckland, for any of those of you who don't know, it's our capital city. It's where almost a third of the country live. in this tiny strip of land between
Oh.
two harbours. It's known as the City of Sails for obvious reasons, but it's just one big CBD on the harbour. So when we get these 7-metre swells, that's 22 feet of ocean swell on top of anything else. It's going to be pretty wet. And so over the weekend into Monday is when we expect this to come through. So yeah, just keep an eye on the news for what might happen.
Hey, Mitch, with the track that it's on, the kind of northeast coast that just got devastated by the last cyclone, are they kind of in that same pattern, like based on, I haven't checked where the track is, but
Yeah.
are they still recovering from the last one?
They are. So there was a lot of landslides in the last one as well, and so
Yeah.
they're still clearing the roads from that. So I don't know what flooding on top of landslides that have already happened is going to do. But you can already see we already have this sort of northeasterly flow coming over the country, which northeasterly flow for Auckland, as we know, is already pretty bad. But then as it's going to get associated with this deep, moist, there's a tropical cyclone coming from our hot oceans up here. Yeah, it's really, really interesting. But as we see, this blue colour here tells us that it's downgrading to just an extratropical. But we get about 3 of these a year. We get 3 ex-tropical cyclones transition over the country. But for this to come in such a direct route and be categorised for so long, like that's Brisbane. That's getting pretty mid-latitude by that point. It's pretty remarkable. Yeah.
You know how common it is to have 2 cyclones on each side of Australia?
Fairly common, yeah. So we have Freddie hanging out in the southern Indian Ocean if you zoom out a bit, but there's not too much going on out there. Is that too? Yeah, this is Freddie here, but just for this to develop, yeah. So you can see that convection over Indonesia at the moment. We're pretty clear other side of that. So yeah, phase 6 MJO, La Nina, hot oceans, and then this. If we jump into the tropical tidbits again and get to like a jet stream map, maybe 250. We'll be able to see that subtropical jet stream.
There's 200 millibar winds available.
Yeah, that's really cool out there. Well, the Alicia Bentley maps, if you go into that, it's nice. That's the first one. If we go South Pacific. Yeah. So this split jet here, that's subtropical, and then a hint of a polar jet down here. And for this cyclone to already be in this wee little shortwave trough coming through, so it's already been passed on, come straight down. Yeah, very interesting what's going on down there. Okay.
Awesome. Thanks, Hamish.
Thanks, Hamish.
Guess we're done.
All right. Thanks very much,
Thank you,
guys.
Isaac and Jason.
Great. Thank you very much. That was great.
Cheers. Thanks everyone for your attention. Thanks for coming.
And let's get those shoveling muscles ready for the 22nd of February.
That's right.